Okay, today's topic, connected bodies in equilibrium. So basically we write out a couple of things like so, attached by some cords there, and then they're attached themselves. So we've got tensions in strings, and we've got weight forces that are acting that we need to look at. So again, the best way of doing these is to resolve horizontally and vertically. Okay, and work from there, and so often we're going to end up with some simultaneous equations and things like that that you need to solve, which you will be able to do without too much trouble. So let's get in there and have a look at a couple of examples. Okay, so here's our first one. So forces acting on two bobs. Bobs are just objects suspended from a line inextensible string. Light means they've got no mass, and inextensible means they don't stretch. Shown at the diagram at right, shown T, find T and M. So T that they're referring to is this tension, which is the same, and M that they're wanting us to find out is this one here. Alright, so as I mentioned on the previous page there, that we did resolve horizontally and vertically. So alright, so horizontally, these two tensions T1 and T2, we can put them in a horizontal component, and we can also create a vertical component for them. Okay, now horizontally we need to also split it in half. So we need to split it, say like through there, and we need to look at the left and the right one separately. So the left hand one, what have we got on that one? Well, we know that horizontally that T Newton, which is heading to the left, if it's in equilibrium, then the bit that's heading, T's pointing to the right there, we need the bit that's pointing to the left, so that's that little green bit, and that green bit is T2 cos 60. So we know that bit. For the right hand one, again, we've now got the tensions pointing to the left, T, and that we know has got to be equal to T1 cos 30. That's that bit pointing to the right there. Alright, what else do we know? Okay, so vertically. Okay, on the left, we've got down, we've got mg newtons, we're told, and then up, that orange one pointing up, there is T2. Sine 60 Newton. Okay, and the right hand one, we've got 5g Newton down, and up we've got T1 sine 30 degrees. So if we're looking at, say, the right hand one, so looking at this side here, from this side here we can rearrange that and we'll get the T1 equals 5G on sine 30 degrees. And the sine of 30 degrees, of course, is 1/2. So T1 is 10G. Now, of course, T1 is 10G and T1's here. So we can then substitute into that and get that T is T1 cos 30 T1 is 10G, cos 30 is root 3 on 2, so 5 root 3G is what T is, and that's what we were asked to find out. Alright, one of the things, the other thing we were asked to find out was this mass, M. There, we're asked to find that. Alright, so we know T now, so we can look at these two. T equals T2 cos 60. So T equals T2 cos 60. And we know that T is 5 root 3G. So T2 cos of 60, cos of 60 I think is 1/2. And so the tension then, T2, is 10 root 3G, which is then handy because we can now substitute that into here, this one here. So mg is T2 sine 60. T2 we now found is 10 root 3G. 60, the sine of 60, root 3 on 2. The g's of course cancel. And so m would be 5 into there, goes in there once, root 3 times root 3 is 3, 3, 15, 5 I should say is 15. So there is our mass. So the two things we were asked to find out, the tension and mass, and we have found those out. Alright. Now, that was reasonably not too bad because of this here being horizontal. Now, there's nothing to say that that's necessarily always going to be the case. So let's have a look at this example. Okay, so when we look at this example, the tension is not horizontal. So we've got horizontal and vertical components of that. And of course we've got horizontal and vertical components of those two tensions as well. Alright, so it just complicates things a little bit more, but we still are looking at doing the same thing. It's horizontal and vertical, left and right. So, the one on the left, if we look at horizontal, we've got those, the 10t cos 10 is equal to T2 cos 60. And vertically on the left, we've got the mg down, and up we've got two things. We've got the T2 sine 60 plus we've got the T sine 10. The one on the right, horizontally, we've got T cos 10. Let's remember that tension is the same both ways. And it equals T1 cos 30. Vertically, there's two components pointing up and one down. The one down is 5G. The two pointing up is T1 sine 30. And the tension sine 10. Okay, so there's our equations that we've got, and we need to then be solving those simultaneously. Where there's a fair bit of mucking around, so you can use a calculator for that, should you wish. Okay, so now let's just make a little bit of extra thought here. Something that I, in my haste, overlooked. When we look at the right hand side, this vertical component of this tension is actually down, not up. So that should be a minus in there. That's what we should be having. So really it's 5G plus T sine 10 equals T1 sine 30 for it. Okay, so this is what we then got to get in and solve simultaneously. There's a bit of mucking around if you want to do it by hand, which you can do it by hand if you wish to. Okay, so if we look at the right hand one, looking at the right hand one, T1 would be T cos 10 over cos 30. Then you then substitute that into 5G plus T sine 10 equals, oops, wrong way, T1 sine 30, which is T cos 30, that's cos 10 I should say, cos 30 multiplied by sine 30. Alright, so it's going to get complicated, so in this case you need to grab your calculator out, do your simultaneous equation things on your calculator, and when you do that you get T is 124.4. Okay, you need to look at the question you're doing, how many marks it's worth, and then, do you want to go down that algebraic path or don't you? In this case, you probably don't want to. It's taking quite a bit of time. Okay, so the other thing we wanted to find out was that mass here, this mass. So again, we've got another series of equations that we would want to solve, but we've already now found T1, so the equations we want to solve is 124.4 cos 10 equals 22 cos 60. And the other equation, mg, equals T2 sin 60 plus T sin 10, and T is 124.4 sin 10. Okay, again, simultaneous equation solver. Could, if you wanted to do it by hand, you could do it by hand. Get T2. Let's go and do this one by hand. T2 would be 124.4 cos 10 over cos 60, and when you do that we get 244.4. And substitute that in and rearrange, and you find that your mass then is 244.4 sin 60 plus 124.4 sin 10 over G, which is 9.8. And you get 23.80 kilograms. And you do that one by hand. Or the simultaneous equation solver should give you the same answer. Alright, so connected bodies. Resolving horizontally and vertically, taking your time to work through it. Use simultaneous equation solver if you need to. Alright, so exercise 14D this is, so this is the last one. Revision next time, test this lesson after that. It's problem set number 9 on your sheet.